Hey everyone, good morning. Streaming a little bit later today. Okay. Okay, so I streamed a little yesterday. I think it was yesterday, but it was basically just trying to get PISCO installed. PISCO is a MATLAB software made by Rodrigo Lobos, and it turns out I needed to update MATLAB, and so all of that was uninteresting and not relevant for the work that we're trying to do. So instead, I did much of that off stream. I've got PISCO working. I'm going to show you what I did, and then we're going to try to implement the use of the support today. Okay, so let's see. So there we go. Okay, so what did I do? Here's the example code for PISCO, and it sets up all the input variables. And PISCO except it does not use input parser. Instead, it uses the order to designate which input variable goes where. And so if you want to supply guess when param, but you want the default values for many others, you have to actually supply the variable for many others, and then you get to supply Gauss when param. So how did I handle this? I created a function called call pisco, and then maybe I could put in like varg in here. Here I could create input parser. Let's add a parameter. Okay, and so now we could supply m as a parameter to call pisco, which will then put it in the right order for pisco sense maps estimation. And so one of these I actually did change the default value of. Which was it? So here I'll say if numl m equals 0, and so maybe I'll put that there. Okay, so this is one. So for whatever reason, I chose to use the default value of threshold in Pisco instead of 0.08, which the example uses. This is a little scary because the fact that the example uses something other than the default value indicates that the results are sensitive to that default value. What is the default value here? Which, yeah, the default value here is 0.05, which is different than the example. Okay. Let's do the same thing for verbose. I think this is the one that I changed. Null space C calculation, maybe? Nope. That's one. That's one. This one. So rather than using power iteration, I found that our data is small enough that we can just use the SVD. Okay, so what happens, we get here, we hit that. That's how fast PISCO runs. That calculated the sensitivity maps. That's even faster than the simple thing that I was doing previously, which is amazing. Not the sample mask, but this. Those are the sensitivity maps that it creates. And then, in this example, there's this thing called the Eigen mask. Well, that's the support. That's PISCO trying to find the support. It's outside of the standard PISCO estimation. And it has its own threshold, the threshold mask. So I changed the threshold mask, which again makes me feel like this is sensitive to that. Let's see how sensitive it is. So what does this Eigen mask thing do? Like I say, it's the support. So I'm returning that support from call PISCO. Those are the sensitivity maps without taking the support into account. That's the support. Now, you and I know we've been looking at the ankle for a long time now. And so this, isn't exactly the boundary of the ankle, but whatever. It's like something less than the total field of view, which is good. And so this is the sensitivity map defined over what PISCO thought was the support for each of these coils. This here is aliasing. It's aliasing, the lower portion of here is aliasing up into the upper region here of this coil. This looks very sensible. What is the problem with this? One problem is it's not perfect. So let's take a look at the example. For the example, it's for the brain, and that is nearly perfect for this particular, like those are the images of the brain. And then you see that the support is nearly perfect. And that's really good. That's the example that comes with the PISCO code. Well, let's say I reduce the threshold for this for the support of the ankle. What does it look like? We're even going to show the true image so we could compare. Okay, so there's the support and there's the true image, and you see this region here. There's ankle, there's leg here, and it's excluded from the support. This is rather bright, actually. And there's a lot of region that's included in the support that isn't included, that isn't part of the ankle, but that's fine. Like I say, as long as we have something better. I'm more concerned about this part that's ignored because that would turn into aliasing the reconstructed image if we were to take the support into account. So what to do? Well, what if we reduce the value of this threshold quite a lot? Or rather increased it. So I increased it to 0.1. Let's try increasing it to 0.2. Okay, we've increased the size of the support. We've gained quite a bit of the ankle. There's still some of this leg that's outside, but not nearly as much. What happens if we go to the 0.1? Okay, that looks decenter. We're still losing a little bit. We haven't increased the support in the region where there isn't an ankle quite so much. So what to do? Okay, so my inclination in a situation like this is try to understand PISCO thoroughly and see if I can't figure out a better way to determine the support, or eliminate its dependence on the threshold or whatever. The issue with doing that is it would take so much time, and it would derail us from our goal of getting the SPIRiT regularization up and running. We do have SPIRiT regularization up and running, but we don't have it taking the support into account yet. Okay, so, oh my gosh, I just updated MATLAB, and now there's a bugs fix and update. There's an update available. I'll do that off stream. Instead, we're going to press forward. So we're going to make this threshold mask a parameter. Huh. It might need to be positive, I'm not sure, because I don't understand PISCO. He groups these parameters. I don't know what this group is all about. Oh, I see. This is him saying that these are PISCO binary flags. We don't need those comments. That's actually a bug. So our hope is that for whatever reason, a threshold mask of 0.1 will be generally applicable for most data, almost all data. Here's hoping. Okay. So now we've got very decent sensitivity maps, and we've got a reasonable support. Let's see what the result of all of these reconstructions is with this new sensitivity mask. And hopefully we'll see that these regions that were bright before are not as bright now. So that's the model-based reconstruction. That's interesting. The noise pattern is very different now. You guys may remember that these regions, like where the sensitivity mask was dark before, it turned out to be bright in the reconstructed image. Let's see if that's still the case. I guess that we could already see that it's not. Yeah. So these regions that were bright in the model-based reconstruction before are not. If Zoom is showing you these details, or if YouTube is showing you these details, or Twitch or whatever, you'd see that there's like some significant noise in the reconstructed image. And hopefully there's not quite as much of that in the reconstruction with gamma. Okay. And it appears that there isn't. Okay, the reconstruction with gamma is significantly better. That's awesome. In some ways, it's significantly worse. There's this bright line here that shows up in the reconstruction of gamma that does not appear in the model-based reconstruction. That's disconcerting. Interesting. Okay. So one thing I realized is that we're comparing the reconstruction of the SPIRiT regularization to model-based reconstruction, but we haven't yet compared it to just SPIRiT. No. SMAPS is not a recognized parameter for SPIRiT? Oh, of course, because SPIRiT does not use the sensitivity maps. Now, here's an interesting fact that I realized over the weekend. If the sensitivity maps were perfect, then SPIRiT regularization would not help. It's only because the sensitivity maps are imperfect that SPIRiT regularization helps. Yep. What's happening? SPIRIT's taking a long time. That's the SPIRiT reconstruction, and it is very good. I'm not sure SPIRiT regularization is going to be better. I guess we'll find out soon enough. Why did that take so long? We could parallelize this. I'm about to parallelize this. Spirit regularization gamma, spirit. In some ways it's better, in some ways it's significantly worse. There is more detail, but there are details that shouldn't be there. We're going to have to look into that, see why that is. Okay. Now, while I'm doing this, let's set up the par pool to use 8 workers so that that doesn't take so long in the future. Before I do this, let's what do I call it? Profile spirit. While it's running, I'm going to keep coding behind comments. I'm really only interested in how long this for loop takes. But as long as we're at it, let's just see what's taking the time. If you remember, we could also make that faster. We don't actually need W as a matrix because we're only using one element of the cell each time. We wouldn't need it as a matrix if we were going to make this faster. Let's see what's taking the time. Let's stop guessing and see what's taking the time. Okay. Pad data. Pad data is taking the time. Okay, let's look at Recon Spirit. How long is this for loop taking? I thought I could see the code, all of the code. This file was modified. Oh, I see. Which is pad data inside of circular convolution 2, I imagine. Circular convolution 2 is padding the data. Okay. And that's taking 17 seconds. The FFT is taking another 13 seconds. The IFFT is taking another 9 seconds. IFFT shift is taking, where does that get called? Well, I guess by changing the code. So this for loop doesn't seem to be taking much time at all. .1 seconds. That's funny. We've got something else going for 17 seconds, and this is taking 0.1 seconds. We've already got this code. Let's see what happens if we parallelize this. because when things are hard, see if you can do something easy. This might actually make it slower. It might make it slower because it's got to distribute memory to different cores and then bring it back. Or it just might crash. That's a possibility too. Seldom met. Dimensions of arrays being concatenated are inconsistent. How is that? Oh. Something that's cool is PISCO, when you download the code, gives you a T1 data set. It's nice if you need one. Now it took 0.09 seconds. We shaved off 1/10 of a second. Oh. Nope, that time it took 0.1 seconds. So it doesn't change the time at all. So it's the pad data of circular convolution 2 that's taken the most time. And that happens here. We should call pad data. We don't need to call pad data on one of these, right? Or we may not need to call them. If max SA not equal to S out 1, then pad it. Max SK is not equal to S out 1. So this says, oh, but I'm going to have to copy the memory. Okay, we're just going to call pad AA. Struggling. There we go. So we only pad A or K if A or K is different than the size that it would be if it were padded. Bet you that gets significantly faster. Let's find out. I think it's going to get significantly faster because we don't have to pad A anymore. So we should reduce the amount of time that we're padding by half. So 17 seconds should go to something like 8. I took Casey Muratori's course for a while on performance, what did he call it? Performance-based programming or something like that. It's an amazing course. It's on Substack. And much of the beginning of the course talks about profiling. And so one way to profile is like you put, basically, it's akin to TikTok. You put the point where you want to start the profiling, the point where you want to stop the profiling, and then it profiles the time in between. And as far as I can tell, he actually makes the best profiler during that stream on his Substack. However, what's happening now is what he calls sampling-based profiling, which I think means every once in a while the profiler asks the CPU maybe, where are you right now? And then that's how he gets an estimate for how much time is taken in each of these things. Okay, so pad data is still taking 17 seconds. That's very strange to me. How did that happen? Did I implement those? Not equal. Yeah, I think that's right. This is me asking, is there a difference between the size of A and the size of out? So here the size of A is 5 by 5 by 8. The size of out is 256 by 256 by K. The size of K, though, is 256 by 256 by 8. So let's make sure. Size of out is 256 by 256 by 8. That's good. We should pad A. So A is now 256 by 256 by 8. That's what we wanted. What about K, though? This should be 0. That's why it didn't make sense. So why did I put a comma 1 there? Oh. Did I mess up this if statement? Okay, so now what's this? 0. And this? 1. Good. Now we should reduce. Okay, so this is, MATLAB's telling me there's a simple way to do this. Consider any instead. If any, what does any do? Determines if any are non-zero? Determines if any is non-zero logical true. Okay. What is this? Any here is true, and any here is false. That's what we wanted. Okay. Didn't mean to have a breakpoint there. So this pad data happens inside of circular convolution, which is also called by SPIRiT regularization. So implementing this little optimization, quote unquote, I mean, this little improvement, let's say, call it, I don't know if it's an optimization. It's also going to make SPIRiT regularization faster, which is kind of nice. A lot of people talk about premature optimization. So you might say, like, your code's not done, it's not fully implemented. Why are you optimizing anything? Because debugging is based on these premature optimizations. If it takes a long time to run the code, it makes debugging that much harder because you have fewer shots to debug in any given period of time. And I've had code that has taken so long that with 2 weeks to go, I knew how many opportunities I had to fix all the bugs. So doing these little optimizations, which take very little effort along the way, improve things. Pad data now, instead of 17 seconds, takes about 11 seconds, and that's a significant improvement. All right. So circular convolution is taking like 89 seconds, circular convolution 2. Where is all that time? This file is modified during or after profiling. Function listing is disabled. No, it wasn't. I did not modify it. Maybe I need to fix MATLAB's bugs. Download this. Oh, yeah, maybe I need to download those things to get the profiler to work. There's another issue with this pad data, wasn't there? Wasn't there another improvement we could have done? Oh, yes. Here. So N is the thing that's large. W is the thing that's not. So W equals pad data. W S image N coils N coils. So we've made circular convolution 2 a slightly more efficient, which is good, slightly more efficient sometimes. If, these things, if A is tall and skinny and K is short and fat, then these will always be called. And so circular convolution 2 is not any more efficient with these if statements. But for our case here, circular convolution 2 is. But we don't have to pad data inside circular convolution. Now, because we have those if statements, we know that W is 5 by 5 by 8. And every time we call circular convolution 2, we're going to pad it to 256 by 256 by 8 by 8. So we could just pad it once here. S image is undefined. What sizes do I have? MN, okay. Now W size 256 by 256 by 8 by 8. We padded it once, and we never have to pad it inside circular convolution 2 again. Let's see how fast that takes to run. Now, if this works, this improvement was inside did I do it in the wrong spot? Inside SPIRiT. So we could do the same improvement here inside SPIRiT reg, and in fact we will. Wow, the time went up. But the time for circular convolution 2 went to like negligible amounts. What just happened? Why did that time go up? The file was modified during or after profiling. Function listing is disabled. I didn't modify anything. I don't understand what's happening, and I'd like to see the function listing. Let's restart MATLAB. I wish that someone from MATLAB was watching this so they could see how much trouble it's become to code with the MATLAB development environment. W has become much larger now. Is it the case that it just like doesn't fit in L2 cache or something anymore? And so now, no, okay, so now we're down to recon spare is 24 seconds. Okay, there's something weird happened. Circular convolution 2 is down to 3 seconds. That's great. So that improvement helped. So let's make sure to propagate it to recon spirit reg. Do you guys remember SW? Here we're calling apply W. Hey, we finished a to-do item. That's nice. Where does SW get set? Are we no longer doing that? I don't believe that. What was the issue with SW? Where does W get set? I thought we were doing it for both all of the case-based data and just the auto-calibration region. I think I'm right. So I think that find W did that go away? Are we no longer doing that? Is SW no longer a thing? It doesn't appear to be. That simplifies things dramatically if true. Okay. I really have changed the code since I did the profiling. It's always been tough for MATLAB to get employees to do technical support for MathWorks, the company that owns MATLAB. You have to go through a year of just on-the-phone technical support before you can become a MATLAB developer, which is probably good training, but nobody enjoys doing technical support, especially straight out of school. You want to do development, meaningful development. Okay, so I got that. Let's see if that still creates a good image. Yeah, something broke. Okay, looks like SW is still being used. I just don't know where. So circular convolution 2 now is going to do the padding with SPIRiT, recon SPIRiT regularization. We fixed something here, and I don't how do I not know my own code? We wrote this. We wrote all of this. This isn't that many lines of code, and yet it's becoming too difficult for me. Where does apply W get called? Wasn't there a place where we were setting SW elsewhere? Didn't that happen? Not a valid condition? Why not? Oh, just want any. So now we're just calling SPIRiT regularization. It's running. Seems to be the case that SW is always S image because this conditional breakpoint's not stopping. Let's get rid of these displays of the sensitivity maps. Okay. Another thing is that okay, so that looks like a good image. Somehow padding the data, padding W, to be the size of S image by N coils by N coils really messed that up. All right. We tried this before, but it didn't work. Why not? Let's find out. Maybe I just did it wrong before. That should make it, we're going to do checks. That should make it so that I can do this instead. Let's see if I can. Takes a long time, huh? Okay, that's good. And do checks passed, huh? Did you all notice that? Or did I put it in the wrong spot? I put it in the wrong spot. Oi, oi, oi. Okay. Arrays have incompatible sizes for this operation. Fails. Fails with a significant error. Okay, so this is where we were at before. I think these two things are equivalent, but clearly they are not. Or is it the sum that's not equivalent? I can't just compare them here because right now these arrays have different dimensions. I do want to see those sizes. BSX fun is going to multiply each pointwise multiply the three-dimensional volume for each element of the fourth dimension. That's what we want, actually. I think. I mean, we're doing a pointwise multiplication here for each coil. So what's the size of out here? Did I forget to do the sum or something? I did. Now does it pass? It does. Let's turn off model-based reconstruction and even Romer reconstruction. Just calling SPIRiT right now. 191 failed. Why? What's the size about? 4 dimensions. Gotta squeeze it. How did that pass checks then? Because we were only doing one set of coils. What's it doing? Why is that taking so long? Where are we? We're in flip dims, apply W applies, recon SPIRiT, 97. Oh, 2 checks is not true. All right, passes. I don't know if squeezing is the right thing to do. Probably is. Well, if we're running SPIRiT, let's profile the thing. Okay, I'm going to hit run and not touch it. We will not be modifying any code at all. We're down to 20 seconds to run this code now. Circular convolution is down to 2.5 seconds. That's good. With a self time for, so it's 14 seconds for circular convolution, which is much better than 90 or whatever it was. Much of it is in the FFT. So where's the rest? Let's look at circular convolution, shall we? Okay, so we've got the code here. It's all in this line, which is to be expected. Convolution slow. Faster than it would be if we did a loop, but slow. This is taking 11 seconds. Okay. In apply W, this is taking 6 seconds, 5.7 seconds. And if we change it to let's run that. Now, circular convolution is taking 15 seconds, and in apply W, this is taking 8 seconds, 11 seconds. Okay, well, 6 is better than 9. So let's do that. We should be able to do the same thing here. This is tougher. This takes 6. Okay, 6 is better than 9. Good. How do we do this? Rep mat in I can't think of a way to do it without a loop. Okay. That might be right. What do you guys think? Think that'll work? Very suspicious. Let's see if dude checks he's in pass or if it even runs. Runs. Fails. think the reason that the adjoint was taking 11 seconds and this was taking 8 or 6 or whatever is largely because we're doing a flip of W in each loop. So what if we just called this flip W? Does that still pass? It does. Let's see if that shaved a few seconds off. It's 40 seconds. The time is very variable. That might be because stuff hasn't been loaded in. Let's see if it is now. That is, the computer hasn't been primed. We can prime the computer by loading things into cache, so it doesn't have to go out to memory to get it. We're loading things into memory, so it doesn't have to go out to the hard disk. Yeah, now it's down to 20 seconds. Okay, so clearly there's some priming going on. Apply W. It's down to 10. I shaved off a second. Better than nothing. Okay, if I could figure out how to take advantage of this new vectorized convolution here, I think that would be good. I think this is the bug. That now passes. File was modified. So apparently if I just look at the file, that's enough to think I modified it. Is that 9 seconds? But we're adding this in, right? So it's 12 seconds. So that actually is slower. And I can't think of a way to undo that loop. So I think the right thing to do then is, we're allocating larger amounts of memory here and we're doing this loop and this isn't helping. So it's wrong. So here's what we're going to do instead. Now, can I sum across a cell array? First argument must be numeric or logical. Okay, so I can't sum across cell to mat. Let's take advantage of multiple cores. What is that? Oh, right. Efficiency. Okay. Okay. Now here's a question. Can I do this? Well, do I actually need a cell array is what I'm about to ask. I think I do, but it's worth trying. I don't really know how to parameterize stuff in MATLAB all that well. It's not crashing. Huh. I didn't need a cell array. MATLAB can figure that out. So that gets rid of the cell to mat, which can't be easy to do. And we're crashing. Why did that happen? Oh. Passes do checks. Let's profile it. Can't look at the code because then it thinks I changed it. It's taking a long time. It's taking a very long time. These latest optimizations don't seem to be optimizing anything. They seem to be hurting things. Boy, oh boy, that took 129 seconds. And it thinks that the file's modified even though I didn't even look at it. Ridiculous. Just to make sure, let's run it again. Yeah, that's taking a long time. So even parallelizing that for loop didn't help. That'd be strange. Flip W actually saved a bit, right? So we're going to keep that. Do we need this repeated matrix now? I don't know that we do. Surely it's not the case that just having the par pull set up is making it slow, is it? Surely that's not the case. Oh, I still have the par 4 there. Okay. As painful as this is, getting it down to about 20 seconds, it was much worse when things were like, 90 seconds. We're at 70 seconds now. And it thinks the file is modified. That is so annoying. So apparently I have to restart MATLAB to get the profile to work. What is going on with MATLAB? Ay, 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 ay. It passes. I do not need that rep mat. And that should make things better. But somehow we're at 70 seconds now. Now we're down to 23. And if we go to apply W, it thinks the function was okay. Let's close MATLAB. We're going to be filing a bug with MATLAB today outside of stream. This is so incredibly annoying. Maybe I should update that first, but shoot, goodness gracious, man. Do you guys not use your own code? That's what I'm asking. This is going to be like the 80-second one because nothing's primed. That took 19 seconds. I was wrong. If we go to apply W, finally get to see the code listing, and this is at 11 seconds still. Is it actually the case that that doesn't help? Because it really seems like that should help. $20 just feels like it takes forever, doesn't it? You know, there's variation in the length of time it takes a computer to run a code. So one thing to see, this is taking forever. One thing to do is run it multiple times, many, many times, and then like take the median value. That's much better than the way I'm doing it, which is just looking at one run at a time in between changes. This is what it's going to be. Okay, this is taking a very, very long time. Apparently that padding really does hurt things. Oh, it's not even running. What on earth? Why didn't it run? Because there's a bug? Okay. We've set up circular convolution 2 the way we wanted so that it like uses BSX fun. That's pretty nice. We've got apply W here. We're down to 3 seconds in apply W. Oh, self seconds. So this is now 11 seconds. And this is 3. It takes 3 seconds to pad that data. That's not what we're doing. Okay, so we're just not going to do that. Oh, we've already padded the data outside here. So we don't need to pad it again. That was silly. That was silly. We just need to flip it now. We don't need to flip it there. Check this out. We could flip it once. No, 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 no. Oh. We pat it and flip it once. Apply W. 11.5 seconds. It seems like it was better to flip it on the inside. It just doesn't make any sense to me. Eleven seconds. Does that make any sense to any of you? Totally. Oh, wait. No, never mind. I'm good. One more. Last try. Okay, once we get it running. Flip, too many input arguments. Did I not do flip dims? Flip dims. Oh, forgot to put in temp. Oh, we don't need that anymore. That we actually want. Okay, so we're going to run this twice to make sure things were primed. Apply W is now 20 seconds, and it thinks that I modified the listing. Ridiculous. Apply W is now 20 seconds. Apply W 17 seconds. It's taking the bulk of the time. This is 11.8 seconds. It's just the way it's going to be. Excuse me. This is the code we're going with. And as I was saying, so we've got a different apply W in Recon Spirit Reg. This one has an SW involved. What? There's flip dims here and there's flip dims here. There's flip dims here and there's flip dims here. So we're always using flip W? Let's do it like this. Do we not need to pad the data? We don't need to store W. We just need to store flip W. Let's see how that does. And we can flip before the padding, which is great. Come on now. Did loading 50 seconds. Let's see what happens if we run it again. Another thing you can do is instead of taking the median time, you could take the best time over a large number of runs. That's like the best that the computer could do on implementing your code. Like I say, if you're interested in any of this, Casey Muratori's class on computer performance-based programming is amazing. It's on Substack, his class. Maybe he calls it performance-aware programming. If this is 50 seconds, I am perplexed. "50 seconds. Apply W is now taking 45 seconds. And this is taking 30. And that makes no sense at all. Somehow doing circular convolution with the flip in there is actually making things faster. I genuinely am perplexed. If we go back to this, and we're padding W, we're keeping the flips around all the time. That took 50 seconds. If we run it again, that took 20 seconds. Apply W took 18. Inside apply W, that takes 5.5, and that takes 12. And I just don't get it. I don't get why flipping here is faster. whatever. I should be able to take this, just put it right there. Keep forgetting to do this. Should be able to do that. Where's do checks? I don't know what it's doing. This might be PISCO though. I mean, yeah, PISCO's fast, but it's not, instantaneous. That crashed. Why? Incompatible. Incompatible dimensions. Where's apply W? Pad data, cert conv, apply W. Flip dims W. W's are created by this point, right? So this is check adjoint. I don't want to check adjoint. Inside of apply W, we must. The size of W is 5 by 5 by 8 by 8. Size of in is 256 by 256 by 8. That breaks. Let's see why. Shouldn't be flip dims. SA is 5 by 5. S out is 256 by 256. Oh. SA new is equal to S. S out SA3 to end. A is equal to zeros 5 by 5. SA size of A is 5 by 5. SA is equal to size of A. SA3 to end. Empty. Good. That should work. SA new. SK new is equal to S out. SK3 to end. SK new. Okay. Still crashes. 37. 2, 1 to 2. Passes. Great. This goes away. So the biggest improvement here is that we got rid of this rep met. Now this should be SW. Crashes. Wait, I just wanted to see if do checks passed. And it does. Okay. Let's get rid of this code. Don't know why we need SW. Here's another consequence of having the same code in two different locations. Find W here is parallelized, but it's not parallelized here. These are two different codes that do the same thing. Okay. That's the image that we're reconstructing. That's the image that we think we like. Okay. Let's set up a parpool. And we're going to copy this code into Recon Spirit. We've got 8 cores running now. That is horrendous. What on earth? Boy, oh boy, pretty tough. Those are exactly the same. Is there some other code in here, something else in here that's setting up a variable that Recon Spirit uses? Nope, it's just terrible code now. What on earth has changed? We changed apply W. We knew we did that. And we added find W, and that's it. Did I forget to look at the output of apply W? I thought we had fixed this. Just keep this in a different desktop. The beauty of source control, huh? You could always go back in time. Well, the good news is now that our spirit regularization does much better than just regular spirit. But the bad news is that's because there's a bug. Okay. I'm going to save this. I'm going to go back in time just by doing a git checkout. So there's no difference now to MRI Recon Spirit. There is a difference to circular convolution. If there's still a problem, the problem's in circular convolution. Let's see how this image looks. Oh, I have got to go.